x is equal to x minus 2 to the third power, we're going to evaluate. Okay, so this keyword evaluate means we're just simplifying. There is no solving involved because there's no equal sign. All right, so in this one we're going to use the function f, so we're using x to the third power. So basically, correct notation, f of 3 is equal to 3 to the third power. F of 3 is going to be equal to 3 to the third, which is 27. So g to the fourth, we're going to be using the g function, or g of 4. So we're going to have 4 minus 2 to the third power, which is 2 to the third power. So g of 4 is equal to 2 to the third power is equal to 8. Okay, so make sure you're paying attention to correct notation. All right, so now negative 1. Negative sometimes can be a little tricky. So we have f of negative 1. Whenever you're substituting a negative number, you should always put parentheses around it. So f of negative 1 is equal to negative 1 times negative 1 times negative 1, which is negative 1. So remember, a negative number to an odd power is always a negative value. So now we're going to look at g of negative 2, which is going to be negative 2 minus 2 to the third, which is negative 4 to the third. So g of negative 2 is equal to negative 4 times negative 4, which is 16. 16 times negative 4 is negative 64. All right, so a little twist on this. If f of 2 is equal to 8, what value of x, or what should you plug into g of x so that g of x is equal to 8 as well? So we need g of x to equal to 8. And we know that f of 2, or 2 to the third power, is equal to 8. So remember, g of x is equal to x minus 2 to the third. So basically, I need x minus 2 to equal 2. So in order to do that, I would have g of 4. That would equal 4 minus 2 to the third, which would be 2 to the third, which is 8. So I am plugging in 4 in place of x. So x would have to equal 4. That's the only thing I can plug in there and get a positive value out of something being taken to the third power. All right, so a few more. Okay, so this one we're looking at x squared. So that gets a little trickier than x to the third. So f of 4 is equal to 4 squared, which is 16. So f of 4 is equal to 16. Oops, I don't know why I put negative 16. Okay, so now we're going to do f of negative 4. So f of negative 4, parentheses around negative 4, squared. F of negative 4 is also equal to 16, because any number squared is always going to be positive. So now let's look at g. So g of 5 is equal to 5 minus 2 squared, which is equal to 3 squared. So g of 5 is equal to 9. Okay, now g of negative 1. G equal to negative 1 minus 2 squared, which is equal to negative 3 squared, which is also equal to 9. So what you're trying to see there is I can plug in two different values into these functions, both f of x and g of x, and I can still get the same output because I am squaring the numbers. So now kind of the same little twist, f of 4 is equal to 16. So I want to know what values can I plug into g so that g of x is equal to 16. So remember, g of x is equal to x minus 2 squared. So if you think about what I did up here, I can have this set of parentheses equal to 4, and then 4 squared is equal to 16. Or I can have that set of parentheses equal to negative 4, and negative 4 squared is also 16. So basically I need x minus 2 to equal 4. So in this case, x can be 6. Or I need x minus 2 to equal negative 4. If that's the case, if I add 2 to both sides, I get x can be negative 2. So let's check to make sure that both of those values work. So g of 6 will be 6 minus 2 squared, which is 4 squared, which is 16. So that works. And then I have g of negative 2, which is negative 2 minus 2 squared, which is negative 4 squared, which is also 16. So both of those values work. So the key there is, since you're squaring the number, I can put in two different values of x into that g function, and I can still get the same output of positive 16. Alright, so that was just kind of a separate little concept of what we're going to do next. Okay, so you did this back in geometry with transformations of shapes. So it says f of x is graphed as the solid line. We need to write the transformation or transformations from the solid line to the dashed line. So what happened to the points going from the solid to the dashed? So the way I do that is I simply take 2 points that are in the same position, and I look to see what happened to get from one point to the next. And if I look what I did here, I went down 1, 2, 3, 4. And then I went to the right 1, 2, 3, 4, 5. Okay, so see if that works for another point. So maybe going from here to here. So if I go down and over, it looks like the same transformation. 1, 2, 3, 4. And right 1, 2, 3, 4, 5. So the transformation is down 4 and right 5. So that was pretty simple. Okay, so since both of those W shapes are both facing up, then we know that there's not a reflection going on. So for this one, it looks like there's been a reflection, because I have the short line here. Well, if I look on this one, I have my short side here and my longer side here, but this one's been reflected down, and this one's also been reflected down. So I know I have a reflection over x. So then I'm going to look to say, okay, so this point right here and this point right here, this one's facing up and this one's facing down. So that's the reflection over x. So then if I look to say, okay, what did I do to get from my solid point to my dashed point? I went left 2, and then I went up 1, 2. Nope, then I just reflected, didn't I? Okay, so I went left 2, but then I reflected this straight up because you can see that this is 4 units from the x-axis, and this is 4 units from the x-axis. Okay, so you could also reflect this over x, so you could bring this up here and then move it 2 units to the left. So a reflection over x, 2 units left. Okay, so let's see if that works for another part of the graph. Okay, so I worked on this one. So I'm thinking this one right here has to be the reflection of this. So the dashed line has to be the reflection of the solid line. So I would reflect this one up, so it would look like this. And then again, I'm moving it 2 points to the left. So that one works like that. So then I can take another point. I can take, let's see what I have, this one. So that one's sitting at 8. So if I reflect that one down to 8, so it would be right here. And then I move it 2 places to the left. I'm sitting right there on my graph. So that one you have to be able to see the reflection. So you also could have moved it 2 units to the left first and then reflected it over x. Okay, so this last one, I'm giving you the function. I'm hoping that you talked a little bit about transformations in Algebra 1, either Algebra 1A or Algebra 1B, or I guess you guys wouldn't be coming out of college algebra, but you definitely would talk about those in college algebra. Okay, so this G, my solid graph, is given to you. So when a negative sits in the front, that's a reflection over x. This minus 2 in here is going to shift right 2. And you'll get used to that because this unit is pretty much all about transformations. And then this negative 3 on the outside is down 3. All right, so I have a better time doing this looking at some specific points. So I'm going to use the ones that I'm showing you here with my dots. I'm going to write those coordinates in a chart. So I have my x and my y. So the first one farthest to the left is at negative 7, 3. Then I'm at negative 5, 0. This point at the top of the loop right there is negative 3, 3. This one is 1, negative 4. And this one is 3, 2. Okay, so when I reflect these points, if I reflect over x, that's affecting the y value. If I shift to the right, that's affecting my x value. And if I shift up or down, this one I'm going down 3, that's affecting my y value. So what I'm going to do is I'm going to take this chart right here and I'm simply going to change my points. And I'm going to go in order, red, yellow, purple, or red, blue, purple. Okay, so if I'm going to reflect my y value over x, this one's going to be a negative 3. This positive 3. That would be, that was negative 5, 0, negative 3, 3. So that would have to be a negative 3. Negative 4, that would have to be a positive 4. That would have to be a negative 2. Okay, so for my x value, I'm going to shift them all to the right 1. If I go to the right on the number line, I have to add 1. So that becomes a negative 6, a negative 4, negative 2. Add 1, that's going to be a 2, and that's going to be a 4. And then if I shift my y values down 3, I'm subtracting 3. So negative 6, negative 3, negative 6, 1, negative 5. So basically, I have my points that I'm just going to graph, and hopefully things work out right. So I've got a negative 6, negative 6. I'll do this in green. So negative 6, negative 6 is going to be right here. I have a negative 4, negative 3, which will be right here. I have a negative 2, negative 6. I have a 2, 1. And a 4, negative 5. So if I connect those points, I should have the same shape but reflected. This right here should be my kind of curved one to match this one here. So you can go through the transformations just to check. So this one, if I would take this and reflect it, I'm at positive 3, so I would be down here at negative 3. Then I would go right, negative 7. Then I would go right 2 and down 3. So unfortunately, I took a little pause and looked at my values, and I messed up that right shift because I only took 1 away from my x values, and I should have taken 2. So I'm going to try to fix that real quick. Okay, so if I add 2, I'm going to be at negative 5. If I take my negative 5 and add 2, I'm at negative 3. Negative 3 plus 2 is negative 1. 1 plus 2 is 3, and 3 plus 2 is 5. Alright, so that looks a little bit better. Alright, so negative 5, negative 6. Graph is kind of small. It's a little hard for me to see. Negative 3, negative 3. Should be there. Negative 1, negative 6. I should have just shifted all my points 1 more unit to the right. 3, 1 ends up being the same one. No, 3, 1 would be right here. Having a rough time. And 5, negative 5 should be here. That green point is wrong. So I should have something like this. That looks a little bit better. Okay, so if I check some points now real quick, this one would have gone from positive 3 to negative 3, right 2, and down 1, 2, 3. So that one would have ended up there. This one, when it reflects over x, it stays the same. So then I go right 2 and down 1, 2, 3. like my points have all worked out